So today's notes are on quadrilaterals and then triangles. So you want that template out for that graphic organizer, and we're going to talk about just the plain quadrilateral first. So a quadrilateral is just an enclosed four-sided figure. And we need to, for measurement purposes, know that the sum of the interior angles is 360 degrees. So if we measured all the angles inside the shape and added them together, we would get 360 degrees. Then we want a quick sketch of a quadrilateral. Again, it doesn't have to be anything fancy, just a four-sided figure. So just sketching any four-sided figure there is fine. And then we'll move to parallelogram. So a parallelogram is a quadrilateral with two sets of parallel sides. So we have a little sketch of a parallelogram there, and I'm going to just kind of blow that up for you so you can see what I'm drawing and put some markings on there. When we're marking parallel sides, we mark them with a little kind of arrow on the side, and we mark them going in the same direction to show that they are parallel. So that's one set of parallel sides, and then we have another set of parallel sides, so we're showing kind of two little arrows to show that that goes with the other two little arrows. Now I also have them color coded, but you would not necessarily need to do that. And on a parallelogram, opposite angles are congruent. So we have this angle here would be congruent and to the one opposite it. And then this angle here would be congruent to the one opposite it. Now another fact about parallelograms is that adjacent angles are supplementary. So we could look at that and know, okay, if that's a parallelogram, then the measure of angle 2 plus the measure of angle 1 is equal to 180. And the same thing would be true, again, adjacent next to each other here, like in the shape. So the measure of angle 1 plus the measure of angle 4 would also equal 180, and so forth as you went around the shape. So that's important to know. Now, as we move through those shapes, the parallelogram had all the qualities of a quadrilateral, and a rectangle has all the qualities of a parallelogram. So everything that's true for a parallelogram, also true for a rectangle. But of course, what's also true of a rectangle is that each interior angle measures 90 degrees. So we have our picture of a rectangle, which then I'm just going to kind of, again, blow up so you can see more carefully what I'm drawing. And it has those qualities of the parallelogram, so it's got two pairs of parallel sides, so we can mark those. Also true of the parallelogram and true of the rectangle is it has two pairs of congruent sides, so we can mark those as well. And opposite angles are congruent. Adjacent angles are supplementary, but we also can put in for a rectangle that each of these angles in the corners for a rectangle is a 90-degree angle, so we put the little box in there to mark that 90-degree angle. So then we're going to move on and talk about square. Everything that is true for a rectangle, also true of a square, but then we'll have some additional pieces for square. So for the square, we have two sets of parallel sides, two sets of congruent sides. All four sides are congruent. 4 right angles, 4 congruent sides. So we have our drawing of a square. We'll take that and Make that a little bit bigger if I can grab it here. And so we want to just make note that the same qualities of rectangle are true. We have those two sets of parallel sides. This time all four sides are congruent. We know that all four angles are right angles. And then of course the opposite angles are congruent because they're all right angles, and adjacent angles are supplementary, and because it's quadrilateral, the sum of all the angles is 360 degrees. So we move on to rhombus. Now a rhombus is a parallelogram, all the qualities of parallelogram, but with four congruent sides. So the things that are true for a parallelogram, sum of the angles is 360, two pairs of parallel sides, opposite angles are congruent, adjacent angles are supplementary. Those things are all also true of a rhombus, but a rhombus has the four congruent sides. So let's take a look at that picture. So we have our rhombus, and we have two pairs of parallel sides. And those sides are also congruent. We've got opposite angles being congruent, or the same measure. And then the issue, or the special quality of a rhombus, is that all four sides are congruent, like the square without the right angles. So it's kind of like a squished square. So the next kind of quadrilateral is a trapezoid. Again, it is a quadrilateral. So it's an enclosed four-sided figure. The sum of the interior angles would be 360. But a quadrilateral only has one set of parallel sides. So we have our trapezoid. Let's just enlarge that so we can draw here. And we've got one set of parallel sides. Now the interesting thing about trapezoids in relation to what we've been looking at with equations lately, now this is also true of parallelograms, but a little more complicated, but with trapezoids, because we have those two parallel sides, and then we have a side kind of cutting through them, that side is like a transversal. So that kind of creates a transversal. And so we again have these like supplementary angles in there that are kind of adjacent, just doesn't work the whole way around the shape. So there are special kinds of trapezoids. One of them is a right trapezoid. So again, that would be a quadrilateral. So four sides, the sum of its interior angles is 360 degrees. It's a trapezoid, so it has one pair of parallel sides, but then a right trapezoid also has two right angles. So we have a right trapezoid, again that four-sided figure, one pair of parallel sides. Let's take a closer look at this. And so we've got one pair of parallel sides, and then the special part about this one is we have two right angles in a right trapezoid. Another kind of special trapezoid is an isosceles trapezoid, and that word isosceles may be familiar to you. We have probably seen an isosceles triangle before, but of course isosceles trapezoid is a quadrilateral, so it has four sides. The special part about this is that it is the non-parallel sides of this isosceles trapezoid are congruent. So we have an isosceles trapezoid, and we have our pair of parallel sides, but then it's the parallel sides that are congruent. Now this also creates two pairs of congruent angles. We have our base angles here would be congruent, and then our angles up top would be congruent as well. So the next thing we're going to look at are triangles, three-sided figures, and we are going to start with the side classification terms for triangles. So you want to flip your paper over to that side. The first kind of triangle we're going to talk about is an equilateral triangle, and that is a three-sided figure or a triangle with three congruent sides. Now, not exactly part of the definition, but if it has three congruent sides, it will also have three congruent angles. So we can draw an example of that. And we just want to draw kind of a little triangle that looks like it has all three sides the same and all three angles the same. The next would be the isosceles triangle, and that would be a triangle with two congruent sides and as a consequence of it having two congruent sides, it will have two congruent angles. So to draw an example of that, I'm going to draw two examples of this. I want you to see one where the angles are acute. So that's isosceles with two congruent sides and two congruent angles. But we could also have an obtuse isosceles, two congruent sides and two congruent angles. The next kind of side classification is a scalene triangle, and that is a triangle where it has three different sides. So triangle with no congruent sides, it's that symbol for congruent, and as a consequence it will have no congruent angles. And so we just want to draw a triangle where all three sides are different sizes. And as a consequence, all three angles will be different sizes also. So then we'll move on to the second kind of classification of triangles. Triangles have two names all the time. Just like you've got a first and last name, triangles have a side classification and an angle classification. So our side classifications were equilateral, isosceles, and scalene, having to do with the number of sides that are congruent. The angle classifications have to do with the angle size. And so we have an acute triangle, and that means all three angles are acute. So all three angles are less than 90 degrees. And we can draw an example of that. And another kind of angle classification is a right triangle, and that is a triangle with one right angle. I'm going to change colors here to emphasize that one. Because you can only have one right angle in a triangle. If you start to draw another right angle in the shape, it would not be a triangle. So we have one right angle, and that would be a right triangle. Doesn't matter which way that angle is facing. Doesn't really matter how long the sides are. We just have that one right angle. And the last kind of angle classification is an obtuse triangle, and that is a triangle with one obtuse angle. And again, I'm going to emphasize that one. Because you can't have more than one obtuse angle in a triangle. If you have one obtuse angle, the other two are going to be acute. So I'll draw an obtuse angle there and make the triangle out of it. So you can see that one obtuse angle. So that was a lot of geometry notes for the day. Bring your questions in to your teacher.